So I'd like to begin by thanking the organizers for allowing me to present this video in this format, and I'd like to apologize for everyone not be there. I was looking forward to meeting everyone. Perhaps we'll still have an occasion to meet in the future. So without further ado, I'd like to start my presentation. Today I'm going to be talking about a work that my master student did, Rithwik, where we're looking at video autonomization for AI, or more specifically for vehicles and vehicles that use AI. Um, Today, in particular, we'll be exploring how to enable secure data sharing for autonomous vehicle deployment or for deployment of any AI element on the vehicle. And this addresses a key challenge that's currently happening in the industry. And towards the end, I will be discussing a case study that we actually did in collaboration with a company to help them sort some of their problems. Okay, so let's actually start from generically what the problem is. So modern vehicles are effectively data generating machines. A test drive can be talking about petabytes of data, not even terabytes that I have in the slides. And actually, this data is critical, not only for training autonomous vehicles, but it's critical for monitoring, diagnosis, fault tolerance, detection, but also for understanding what is going on in terms of vehicles and for sharing this data. Uh, However, as everyone here knows or probably aware, uh, data that you collect from vehicles may contain sensitive information. Now, in Europe, we have something called GDPR, which we all must abide to by law, which effectively states that any data we share must be anonymous. So we cannot have anything called personally identifiable information in it, which means something that could uniquely identify a specific individual or their beliefs or their gender, ethnicity, uh, religious beliefs, or any protected information. Now, some of you might ask, why do we want to share data in the first place? Well, I'd like to begin with 2 points. Well, first of all, when you do drives and etc., you might share within the company or with suppliers. A tier one supplier might want to share with the OEM and vice versa. But also, in order to really solve this autonomous vehicle dilemma, we really need to work together. We can't just have one source of data. And so enabling this data sharing in a privacy preserving manner is essential for the industry as a whole. And so our question was, how can we do blurring and anonymization on video without actually losing usability of these videos? And we'll talk a little bit more about this trade-off later on. Okay, so let's actually talk about a little bit about data sharing. I kind of hinted it a little bit, but data sharing matters because it accelerates innovation. It allows faster machine learning development. It allows to cover edge cases. As we are all well aware, probably in this room, these days vehicles can quite comfortably sit at level 2, or what it is called level 2 plus 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 plus, which means it can do a lot of the features autonomously without any issues. The edge cases is where things fail. When you have the flashing light in your camera sensor, when you have this little bit of blur, and these things can cause huge damages. And the fact of the matter is that in a test drive of 4 hours, these edge cases might only ever appear one or two times. And so sharing these edge cases and making sure that we can all learn from them is of paramount importance because we need to create a large data set of these. It's also cost efficient. If we share the data, we can then, don't have to run a million test drives. And finally, it also allows for diversity, different scenarios, different camera settings, different formats, and sharing these with a wider community of researchers and industry alike allows for a better data set for everybody to learn from and therefore a better solution. And then taking a little step back and looking at why we are looking at this in terms of anonymization and security, well, regulatory compliance, but also standardization allows for industry-wide compliance in a way where we can make it easy to share data. So it's not I anonymized, you didn't, and therefore the data set is a mess now. So what is the problem? Now, this is from my experience working with several companies. Probably should name them, given the fact that I'm calling them hoarders. But let's say some of the largest OEMs on earth. This data is being hoarded. And not only what I mean by that is they have ginormous amounts of data that is not being shared around, all for fear of breaking GDPR. Now, naturally, there are also some other fears around competitive advantage, etc. I will not be addressing those. We're focusing purely on this privacy thing. And this is something we've heard firsthand from suppliers we work with. And indeed, the reason why we started this project was because a company came to us and asked us to solve this problem. And at the end, we'll be discussing how it went. Now, let me talk a little bit about GDPR compliance. Now, I realize this conference is in America, so GDPR might not impact everyone. However, every country has their own bespoke set of privacy laws they need to abide by. So, in essence, now GDPR is a ginormous document that I won't ask you to read for this meeting, and I won't summarize wholly, but in practice, has the following thing. If you're going to process personal data, you need consent. You can only share personal data for the purposes you get consent for, and you have to limit it. You should collect only the data that is necessary, and you should not keep the data longer than needed. Now, in practice, if you're accessing a website and asking for cookies or collecting data about the user, it's a very clear one-on-one interaction between the user and the supplier. And therefore, you have this consent in place, or an ability to ask for consent. I think you all agree, if I'm recording a video of a public road in the center of Birmingham, where I'm from, you get hundreds of thousands of people, potentially thousands of people in the video. None of them can give you consent, or indeed, it is not feasible for me to go ask and get consent. So getting this is out of the question. Anonymization is the only solution to make sure we collect this data. Getting consent or having de-anonymous data is not anyway an option. Now, there are several things that are characterized as personally identifiable data. The two things we initially focused for were faces and license plates. These are all uniquely identifiable things. I think you all agree here that a face is a pretty important part of who you are. But then a license plate. A license plate is a unique identifier to your home address, to your car. Once again, GDPR protected. I'd like to also add towards the end of the video, of this work actually, we discussed and looked at other aspects. Specifically, we looked at political messages as another important protected aspect of GDPR. The reason was that we actually encountered some across the videos. And indeed, if you're driving around a parade or some houses, these tend to appear. The final note I want to put, some of you at this point might be thinking, all you have to do is blur out the faces and the license plate, and you're completely fine. Why are you worrying? Well, I'd like to add that even blurred faces may be identifiable, and blurring has some big downsides we'll be discussing in a second. Here on the right, you can see that this is not just a matter of, a few fines or a slap in the wrist. 20 million euros or 4% of global revenue, that could cripple some companies. All right, so before I go on, I want to kind of introduce to you our solution. Now, we have this framework called Blurred Lines, and it effectively takes raw video data. Now, we focus solely on camera data for the purpose of this work. In the future, we can serve further aspects, but camera data we found was the most crucial one, since vehicles these days come already equipped with several dozen cameras on average. And we followed a pipeline that had, from the raw video, we segmented, did a bunch of stuff, but the core things were with 5 different detection methods to really go in depth, finding all the different aspects that were GDPR protected. We had multiple blur and general anonymization techniques on the video, and eventually we created a clean video that we then shared with the partners who needed it. And this video, our aim was to create the best possible video that would still be usable for training, for information, for risk analysis, etc. And the key innovation here that we had multiple redundant methods, because unlike a lot of machine learning experiments where you get 97% accuracy, woohoo, I passed. Here, it was 100% or nothing. Perfect detection, according to GDPR, is the way to go. And so that had a lot of risks, and we'll discuss this kind of trade-off later on a little bit more. But this is the general framework. And let's discuss a little bit of this thing I said about 100% accuracy. What do I mean? Well, according to GDPR, it's not that I have to make my best effort to protect as many faces as possible. Any personal identified information gets me fine. So it doesn't matter if I've protected Bob, Jill, and Alice, and their faces are blurred. If Eve's face isn't, then we have a problem. And that led to a lot of difficulties. Now, I don't know how many of you have played with all the video data, but the data isn't always perfect, dare I say. There's a lot of difficulties. It's not exactly straight faces that you can detect and go, okay, that's a face, let's blur it. Here you can have some pictures. You can see, sometimes you see half the face and you only blur half of it. That's a huge issue. Is it still anonymized now? Can I say I can recognize half a person? Lighting conditions, shadows, motion blur is a huge issue. Your car is moving, sometimes moving fast, so it's very much a detect object. Now, this is a double-edged sword. Sometimes a blurred video is good because it by itself anonymizes itself, but actually this couldn't guarantee. It just makes our machine learning methods detecting people and then blurring them much harder. And angles are a huge issue. We found this was particularly pertinent to OCR, which is a technique to scan text in an image. The angles really messed up the ability to detect this. And so what did we do? We knew that we had to have multiple detection methods. We couldn't afford mistakes. And so we had several layered approaches of detection. Not only that, we had layered approaches of blurring in case we had any doubt that we were covering the full face, for example. So we over blurred or over anonymized just in case. Because once again, in this case, you can't mess around. We'd rather have a worse video than not protect a PII. So the 5 detector methods were done in an ensemble approach. We had traditional computer image methods, so hierarchy cascade. Anybody who's done a bit of machine learning, computer vision should have seen it. This is really fast and lightweight, so it works very well on the easy cases. We then use some deep learning methods. We use YOLO, which is the state of the art for object detection. It found all the things, and then etc. We had a specialized face detection just for the face that could identify faces, not only just the objects. We use OCR-based recognition for the license plate, and when that didn't work, we used a step-by-step approach of looking for the whole vehicles and then identifying the area where the number plate would have been and then over-blurring. Now, please note, throughout our process, we had a lot of overcorrection. Sometimes we saw a car but didn't see a number plate, right? Because YOLO found the car, we couldn't detect it with OCR, so we just blurred the whole bottom half of the car. Now, some of you might think that's a pretty bad job. It kind of defeats the purpose or etc. But we then did a trade-off analysis to see what we lost and what we gained. And obviously what we gained is anonymity. What we lost was some information about the vehicle specs. And we ran some models to actually evaluate this. Now, this is kind of what I was talking about in NATO. Now, if you have a full... So what we mean by blurring. Now, a lot of you know blurring, you can get a little thing, you pixelate it, and now you can't really see it, or you vaguely see a silhouette, like my background right now, it's all blurred. Now, whilst that works great, and it's a natural way of doing it, I think you might notice, for example, right behind my head, you got a lamp. And just because I blurred it doesn't mean you don't know it's a lamp. And so the fine line we're trying to cross is blur enough so it's anonymous and you can't recognize a face, or rather you can't recognize a specific face, but still have enough details that a machine learning element later trained on this data set could learn something from it. And so we use different things. We use Gaussian blur, which is a traditional blurring technique. We use pixelation, which is kind of trying to more in-depth cross out an image. We actually use black boxing sometimes, which is just draw a black box around a person. That's when we felt the blur wasn't, etc. And then we actually tried some more interesting approaches. So face swapping. So I wanted to say, well, I've blurred the face, but I still want it to be identified as a face. This will help future training. So we did a face swapping technique to try to figure out where the faces still were and maintain this information, which we found was very important. And yeah, so the level of privacy can be adjusted, the level of materiality, there's a kind of relationship. The more private you are, the less machine learning you have. This is a fundamental tension, right? So if you're gonna use a data set for training, that you then want to use to deploy aspects of your car in the future world, lane keeping, autonomous driving, if you want to get there, you need rich training data that contains all the details because you want to be able to spot the old person crossing the road and know it's a person. But the data you train that car on needs to be anonymized if it's shared from someone else. So there's kind of like this tension. The more anonymized, the more information I lose. but the less anonymized, I can't share it. And so we were kind of trying to draw this line. Make sure we're GDPR compliant, but still useful for training machine learning. And so we kind of use some context-aware anonymization, which means that when we saw a person, we blurred it enough so it wouldn't be recognizable as someone specific, but still allowed enough information you could still tell it was a person, maybe by enhancing the silhouette. And we use a bit of techniques around this. And then once we had this framework, we called our industry partner and said, share some video with us, we're ready. And they did. They made us sign an NDA. We followed their cybersecurity policy. We went on their own servers to process the data. So they shared it in a de-anonymized way with us, and we ran it to our framework. This was some real automotive data from inside the city of Birmingham. Highway, it was parking, there were different weather conditions. It was several hours of footage run from a forward camera and a backward-facing camera. And what we achieved, and you can see it here at the bottom, was really high detection across all the things. And that was really great. But we weren't actually, well, we here say it's near 100% accuracy. And I said at the beginning, we needed 100% accuracy. What did this mean? So there were some extreme edge cases. Now, worth noting, when we say near 100% accuracy, in these edge cases, it doesn't mean we failed. It means we just had a lot of black boxes around the thing, which lost a lot of utility. Now, the industrial partner was fine with this. They'd rather have complete anonymization. But we need to be careful. So this trade-off, once the condition gets bad, the anonymization wins and the machine learning utility really loses. But we needed the proper safeguards. We needed to make sure that GDPR came first. Now, we have this tool available. So this is an early version of the tool that allows all these things I mentioned. You can quite easily use it for your own testing. We have different compliance levels. Remember, GDPR strict is the one that gives you a lot of black boxes. So you can test it on your own data. Like I said, it's currently being used by our industry standard, and he gives me feedback every year. And I'm actually extending it with other students right now. It's fully available on GitHub, so I encourage everyone to go look at it afterwards. And yeah, so this kind of was a success. We kind of successfully handled this trade-off, and I encourage everyone to give it a go. The architecture is you have a video, you can choose which method to use, you saw the command line options, it then does a decision fusion, and if it's not 100% certain that it's detected something, then it uses the most conservative blurring method and moves on. Like I said, the case study we used at over 50 hours, we had actually really good accuracy, and the average processing was actually quite fast. And it had some false positives by design, which we overcompensated. Worth noting, our industry partner told us that by the end, they still had to do manual annotation, but it was a lot easier than doing it overall. There was a lot of challenges and lessons learned. It's quite hard to balance accuracy and speed. Diverse video qualities was particularly difficult, but overall, we actually managed to achieve a really good level of anonymization at the loss of machine learning utility. And on average, that was the biggest trade-off. So we really need to work on making it better, potentially using some post-processing on the video to actually enhance the blurred out images, maybe with some generative AI we're considering. We're really happy with what we did in this initial work in progress. We want to make it even better for enhanced detection of edge cases, integration with federated learning frameworks, so we can put different videos together, and then maybe it's okay if one camera is over blurring because we have another camera that's collecting some video data. And then maybe some additional PII types, tattoos, distinctive clothing, etc. I hope that people will take kind of inspiration from this and start considering this in their own problem. I think we do need to do a lot more video sharing in this field in order to really advance it, but we need to do so in a privacy-preserving manner. And so, like I said, data sharing is essential. GDPR compliance is achievable, which is great. We don't need to hoard our data. Our initial approach shows we can actually get a really high level of accuracy, which is great. And it's industry adopted, so it can give you some guarantee that it might be used for your tools as well. That's all I had to say. I'm so sorry that I can't be there with you all to discuss this further. However, if you are interested, please do email me at my email and do check out our GitHub with the whole dataset. Thank you so much for listening. And yeah, email me if you have any questions. Have a great rest of the conference. Thank you very much.